again.
Lock in, Nick. Lock in.
Okay, I forgot to start recording. So, part two. Um, Draw conclusions given an experiment, observational study, or data collected from a survey. Experiments are going to show cause and effect. Observational studies are going to show correlation and association between the variables observed. And then surveys are going to show characteristics of the population of interest, like what you're going to learn this next chapter are p hat and then x bar. Question two. Who joined?
Gulam.
Oh, shout out Gulam. Welcome back. Okay, question two. I cannot copy this image. Hold on. Here we go. Randomly select individuals given a random digit table. So first, make sure you made it clear how you labeled each experimental unit. So assign each individual a number 1 through, for this case, we'll say 1 through 20. Oops. 1 through 20. And make it clear that you're omitting values above 20. So that if you start off at like 27, you need to make it clear that you're not using that number because that won't apply to units. So omit numbers above 20, and then you're going to take all 2-digit values like this. You're going to separate them into 2-digit values. And this is the first one that isn't above 20. So this is the first subject we're
Zero.
going to sample. So this one we can use, this one we can't, 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 this one we can, 0, 5. 26 we can't, 99, so on, so on. Does that make sense to everyone? Yes or no?
Yes.
Okay, thank you. Uh, Question 3. Determine the sampling technique. Don't forget about multi-stage sampling. I'm just gonna start typing because my handwriting on here is pretty bad. So first of all, what are the sampling techniques? Ian, name one.
What
Name a sampling technique.
is that like the census and the other
You
one?
said simple random sample? Okay.
Oh,
Okay.
yeah.
Mohammed, name another sampling technique.
Would cluster be one?
Yes. Ian, name another.
Um, um,
Stratified?
um,
Okay. Alvin, name
yeah.
another.
Wait, what?
Name a sampling technique.
A sampling technique? Oh, random.
I already said
Super
that.
random.
Systematic?
Oh,
Okay. And then
yeah,
there's
yeah,
one
yeah,
more
yeah.
that you guys didn't go over, but it's called multi-stage sampling. And this is just a combination of any of these. Like there's multiple that you're going to use. So, and I'll do an example of each one. But the point of a simple random sample is that every combination of um, of individuals has an equal chance of being selected. So 1, 3, 7, and 9 all have an equal chance of being selected to 1, 2, 3, and 4. A cluster sample, let's let's divide it into this. Where these squares are our clusters. A cluster sample is when you randomly select which cluster gets sampled. So whether it's the hat method or that random digit table we just went over, you'll randomly select one. So let's say we select 2 and then sample everyone within that cluster. A stratified random sample is where you're guaranteed to collect data from someone of each strata, but which individual is selected is what is randomly selected. So if these each have a number 1, 2, 3, 4, 5, 6, let's say in this strata 3 and 5 get selected, and then in this one it's 1 and 5, and then this one it's 6 and 2, and then in this one it's 1 and 3. That would be stratified. And then systematic, oh, I went way too far back. Systematic, let's say you have a list of people 1, 2, 3, 4, 5, 6, 7. you're gonna randomly select what number you start on. So let's say 3 gets randomly selected, and you want to do every third person. You'll go 3, and then you'll go 6, and then you'll go 9, and then that just repeats. Multi-stage is any combination of any of these sampling methods. Does that make sense to everyone? Questions? Okay. Number 4, be aware of the most important reason for a random assignment in context. Random assignment is to eliminate bias, and the way it does that is it makes two treatment groups. Where's my mouse? Two treatment groups as similar as possible. So the group in here is as close or as similar to this group here as it can possibly get. So that way you can ensure that any change in the response variable is due to the treatment alone and not like possible confounding variables. Questions? Bro, please talk. This is actually so miserable.
No
We got it.
questions.
We
No
oh wait,
questions.
Ian.
No questions.
Okay,
No
okay,
questions.
okay. Um, I think I skipped 5, but determine if you were given a match, pair, experiment, I think it's supposed to say, a completely random experiment, a block design, or an observational study. So first determine whether treatment is assigned. If it's not, then immediately you'll know it's an observational study and none of the other ones. And then second, determine whether it was split into groups based on commonality. So if it's split into gender and male, then obviously you know it's a block design, right? Because they were blocked based on that commonality. A completely randomized experiment, every subject is going to be randomly selected to receive either one treatment or the other. And then a matched pair experiment, you yourself are the control. So you will receive both treatments. Yeah, you will receive both treatments. That's the difference between each one. In 6, recognize treatment experimental unit levels given an experimental design. I actually found an MCQ for most of the ones after this. Let me get a screenshot. Hold on. Okay, we did this. Oh my god. We did this at the talent on Saturday. So if you were there, you probably already saw this. But before taking an exam, students either... I can't read that. Before taking an exam, students either went to bed at their normal times or were sleep deprived for 4 to 8 hours. 4 or 8 hours. Half of each group were given a caffeine pill before taking the exam. Determine the number of factors, levels for each, and number of treatments. Then I'm going to take another screenshot of the answers because that is actually hard to read. Can you read that?
Could you increase the size, perchance?
In this case, size matters. I cannot read it.
I probably should have just typed this out. Is it easier to read if I just put the doc up like this?
Yeah.
Zoom
No.
in.
No.
No.
Can I zoom in? Does that make it any better?
A little bit.
Not really.
Okay, whatever. I should have thought about this earlier. But the answers are either 1 factor with 2 levels and 5 treatments, 2 factors, 1 with 1. Why am I even reading this? You guys can't read the question. Should I just skip this one? But the idea behind this is that you can have 1 treatment with varying levels. So you can either, so like if it's a drug, you can give them like 2 milligrams, 6 milligrams, or 10 milligrams. And that's the idea. It's the same treatment, different levels, so technically it would be like multiple treatments. Does that make sense to everyone?
Yes.
Okay, cool. Number 7, understand and... Oh, I skipped this one because it's not really a question. Number 8, recognize the control group given an experiment. And then I have an FRQ for this one that we also went over at the Talon. Hopefully you can read this one.
Wait, do you want us to read the question or?
Yeah, do you want me to read it?
No, like I can actually not see anything on my side.
What do you mean?
It's just like your blank screen for me.
What am I screen sharing? I'm screen sharing Paint, no?
I could see it.
Okay,
I
cool.
can see it also.
Ian, leave and rejoin maybe.
Is he back yet?
Ian? Oh, I don't know, maybe it's frozen. But does anyone have an answer?
Oh, well, it's controlled because it has treatments. Or is that, wait, is that how it works?
It's not always controlled simply because it has treatments. A lot of the time it's controlled because there's treatment as well as a lack of treatment. Control is important so that you have a
To
so that
compare?
you have room for comparison. So in this case the control would be the message only.
Oh.
Yeah, does that make sense?
Oh, so like the control group would be like
Oh, the
having the
control group's
message.
the one with no treatment.
Yeah, exactly. That way you can compare it to the treatment group.
Is there a term for the, I thought
Didn't we
there was
do
a
this
term for the
already?
groups with treatments.
Sorry, what'd you
Or is that
say?
just called treatment?
What'd you say?
For some reason, I thought there was a term for like the groups that have treatments, or is that just called treatment?
That is called treatment group.
That's just called treatment group. Okay.
Yeah. And then wait, who's 8L21? Okay, whatever. Number 11, be able to recognize potential confounded variables in any type of study. And then this one I stole from the same question. So for those that were here during the Talon, I think we did this during the first half of the Talon.
Can you hear me?
Yeah.
That's me, Isabel. I was at Talon.
Oh, okay. So you probably know most of the MCQ and FRQ answers that I'm going over. Oh, I copy pasted the same thing. Hold up.
I was about to ask, like, are we supposed to answer the same question again?
No, 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 no. Bro, what? This is so miserable. Hold on. But it's the question is there may be some lurking variables that contribute to the customer's response. Name a few. There you go.
Could you explain the difference between a lurking and a confounding variable?
Um, lurking is a general term. Confounding is a type of lurking variable. There are other types of lurking variables, but the only one you learn is confounding. So in this case, they're synonymous.
Wait. Oh.
Meaning the same or?
Yeah, they mean the same.
Okay.
Oh, I thought
Um,
so. Miss Miller said that like confounding variables are like lurking variables that we know of. Is that
Basically, yes.
so? Like, if we find a lurking variable after, if we find a lurking variable during the experiment, it's a confounding. But afterwards, after the experiment's over, it's a lurking variable, right?
If it's accounted for, then it's a confounding variable.
Okay.
But in almost every actual AP FRQ, they're going to ask confounding. And if you mistake lurking for confounding, they won't mark you down for it. I want to say they won't mark you down for it.
Okay. Okay.
did my Wi-Fi crash?
I can hear you. Okay. Does anyone
Oh,
have
it did.
examples of lurking variables
So
here?
a lurking variable could be whether the type of music the customers enjoy
Yeah, so what they typically listen to, that could have something to do with it.
and their electronic devices because they're calling what's it called? Like they're calling customer service for a technology company. So
So the type
Their
of
device could
device.
be messed up.
So like the issue that they're calling for. Yeah, that would definitely be a confounding variable. Those are two good ones. So I'm just gonna move on to the next one after that. But more or
Um,
less, yeah. Go ahead.
I well, like, is there like multiple answers that could be possible?
Yes. Because
Okay.
lurking variable or confounding variable is anything that causes a change in the response variable that isn't the explanatory variable. So anything that affects that could be considered a
Oh,
confounding
I had
variable.
a question on this test.
Yeah?
So like if we get a answer on the if we get an answer that could be correct, but it's not on the answer key, it'll count as like correct, right? It'll be right.
Yeah, because the AP problems don't have an answer key, they have scoring guidelines. So there's criteria that your answer has to meet, but there's not a single one correct answer.
Oh, okay.
Yeah. Um, 12 isn't a question. 13, recognize the different types of bias and sampling errors. Okay, Gavin, name one type of bias. Gavin? Okay, someone else name a type of bias.
Wait, no, but Miller
Non-response
said, but
bias.
wait,
What? Hold on, non-response. What are you saying, Gavin?
uh,
Confused me.
but that was one of the answers from the quiz, and a lot of us got it wrong because it was wording. She said the right answer was wording bias.
Wait, what?
Wait, what are you
I'm
talking about?
confused now. What are we talking
Yeah,
about?
what are we talking
Wait,
about?
wait, we're talking about biases, right? Non-response, response, variable bias.
What is variable bias?
Wait, no, wait, I can't think.
Okay, non-response
Wait,
bias, response bias, there's wording bias, and then there's voluntary response
Isn't there
a
bias.
also survey bias?
voluntary. That's what I was trying to think of.
What were you saying, Zaid?
Isn't there also survey bias?
Survey bias, that's the same thing as, well, what do you mean?
Uh,
That's the same thing as voluntary
I don't know.
response.
I remember I went to like a tutoring and one of the answers Miss Yarbo said was survey bias.
Survey bias, I'm pretty sure is synonymous to voluntary bias, because the idea is that
Okay.
only people who feel strongly on the subject will answer.
Okay, because that confused me.
Okay, wording
Wait,
bias is when the wording of the question very blatantly sways you towards a specific answer. So one of them we went over during Talon was saying, do you think it's positive or it's good for the U.S. military to retreat? Blah blah blah. And someone said that that makes it sound cowardly, which is true. So it makes us sound scared. So a lot of people are gonna say no, that's not good. When more objective wording would prompt different results than that question would.
oh wait,
Response bias. Um, the example I always use for that one is GPA. When you're asking people their GPA and they're around their friends, they don't want to sound dumb, so they're going to make their GPA sound higher than it is. So if they have like a 3.2 and they're like, "Oh yeah, I have a 4.3," then their response was altered because of the people they're around. Non-response bias, that's just that the people that were a part of the sample didn't respond because they couldn't be reached or they chose not to respond. And that brings up problems because it's non representative of the population if their response isn't recorded. Yeah. Any
Nick,
questions?
I have a question.
Did you
Yeah.
do, wait, did you say response bias
Yeah, I said
already?
response. That was the GPA problem or GPA
The
example.
GPA one?
Can you I always had a question between non-response and voluntary. Miss Miller said like non-response, you are expected to respond to the survey, but you chose not to, or you just can't answer it. Involuntary is like you have the option to do it and you just chose not to.
Yeah, exactly. So the idea of non-response is, let's say they do a simple random sample. They label like they label everyone 1, 2, 3, 4, 5, 6, 7, blah blah blah, and you're number 3 and you're selected. So they have to ask you that question to have your response because you were selected to respond to that. If you don't answer, then someone that was randomly selected, their response is not recorded,
Oh, okay.
and then it's not completely random anymore because someone who was randomly selected did not respond. Does that make sense? So it's
Yeah.
no longer representative of the population. Okay.
Hmm.
And then Alvin, did you have a question?
Wait, is convenience like a bias or no?
Convenience sampling is gonna lead to undercoverage. Yeah, convenience sampling is gonna lead to biased results, which
Okay.
is gonna be undercoverage, yeah. But these are the main ones. Number 14, recognize a problem that may have occurred in the designing of an experiment. I have an MCQ. Again, I hope you guys can actually read this one. Here, I'm gonna make it smaller. When my PC stops. Oh, wait, never mind. Can you guys see this?
Can you make it bigger?
When I make it bigger,
Can
the
you
pixels get like really bad.
Okay,
can you make
I'll
it like
try
a
to zoom
tiny
in.
bit bigger? Just like a tiny bit.
Well, actually, since the pixels get bad, maybe if you make it smaller and we just zoom in
N-
to the question.
I don't think it's gonna help.
No, that don't work.
You wanted to
That
send the question, like the picture of it on Discord and then answer it
Yeah,
together.
I'll send it. It's in general. 50 migraine patients are randomly selected from hospital records. Half the patients are told to drink ice water and sit in the dark when they next experience a migraine. The remaining patients are told to use neither of these possible remedies. Participants then report back as to relief, if any. Faults of this experimental design include all of the following except.
Um, is it B, confounding variable?
No.
Okay.
Because
is it D?
it's asking what part of this is not a fault of the experiment. They didn't really account for any confounding variables such as like age, which may cause headaches and make it harder to get rid of headaches, and that was never accounted for. So accounting for confounding variables still is a fault of this experiment.
Is it A?
No. At the
No,
beginning, oh wait. Yeah,
because
no.
it doesn't say they randomized. Oh, it does say randomly
Yeah, it is
selected. Never mind.
randomized.
I forgot this one.
Or is it D
It's not E.
or D?
It's not
Yeah,
D.
he just went through the letters.
It's C.
Hey,
He
how
just
is it
went through all of
C?
them. Because they didn't blind, but that's not a fault of this experiment because blinding can't really be employed in this case. Because
It can't?
no, because the treatment in this case would be to sit in a dark room and drink ice water or like not drink ice water. And how you're gonna know whether you're drinking ice water or not. There's no way to blind that. So it's not something that can be included
Oh.
in the survey. Therefore, it's not a fault of the survey.
That's such a
I wish,
hard question.
yeah, I wish there were more to
So
go over
unclear.
for that, but I couldn't find any more MCQs like that. 15. Know the most important aspect of random assignment. Does anyone want to guess?
With the what? The most
To reduce
the
variation in data.
Yes, exactly. So let's
Yay!
say treatment is divided into two groups. One will receive treatment 1, one will receive treatment 2. You want to have these groups be as similar as possible so that any changes in the response variable can be credited to the treatment. Does that make sense? Because if these groups were diverse then and their responses were different, then obviously it would be because of like what's different in each person. But if they're mostly like the same, then the response is going to be caused by the treatment alone. Does that make sense to anyone or to everyone?
Yeah, that makes sense.
Okay. Questions on that one? Okay.
No.
You said that's the most important aspect of randomization
Of random
or
assignment.
random assignment.
And then, can you see? Hold on, I'm gonna just send it in the Discord again.
Oh. B.
Is it
Yes.
for question 10?
Yeah. It is B,
Oh
because you
yeah,
make your
B.
treatments group as similar as possible, like we had just said.
I'm locked in for that one. I'm locked in for that question.
16. Remember, a strata is for sampling, while blocks is used for experiments when dividing into homogeneous groups, common groups. I have an MCQ for this one, but I don't have anything to say because it's not a question, or the thing on the what you need to know is not a question.
Oh my, I can barely do this.
Which of the following is a true statement about blocking? A.
Read all the answers, or read all the.
Um,
Yeah.
You ready?
you want me to read everything out?
No,
E.
just. Yeah, Gavin's right. It's all of the above are true statements.
Oh shit.
What do you think it is, Ian? Okay. Okay. Um.
Can you
Yeah.
so is blocking, like, can you go into more depth about blocking?
Okay. I'm just gonna be general because I can't think of an example right now. Blocking, you divide groups based on commonality. So let's say,
Oh,
yeah. So let's say you're trying this new drug and you think gender affects whatever it is you're measuring, heart rate. You think gender affects heart rate. So you're gonna divide it into groups of all boys and then a group of all girls. And then within each group, you're gonna assign a treatment. So I'm just gonna call that treatment, and then you're gonna assign a control. So this is probably gonna end up being no treatment. And then you do the same for the other side. And then you compare within either block whether the treatment caused a change from the control in boys, and then whether the treatment caused a change from the control in the girls. And then remember, random assignment still applies here. So you randomly select the 25 that go in this group, assuming it's 50 boys and 50 girls. You randomly assign who goes in this group, and then you randomly assign the 25 that go to these groups. Does that make
so
sense?
blocking is like all like boys and then girls, right?
Yeah, you divide them so that everyone within each block is the same. So like this
Okay.
entire block will be boys and this entire block will be girls. Another common blocking thing is age. So like people below 20 are here and then people above 20 are here. So everyone in this block will be below 20 and then everyone in this block will be above 20. Does that make sense?
Okay.
Yeah.
Okay. I think I already addressed number 1 on the free response questions. If not, let me know and I'll go back to it because I'm going to start on 2 right here. Explain in detail why a larger sample size is preferable. Does anyone want to answer that?
You
Reduce
said explain in
variability.
detail why a larger sample size is preferable to get
Yes.
a, what do you call it? Because for a larger populate, not a larger population. I forgot the wording.
Sample? Larger sample?
Um, wait, what?
Never mind.
Decrease variability or something like that. Increase? I don't know.
It
Reduce
does
variability.
it does reduce variability, but
To get a better
that's
idea of the general population.
yes, because as sample size increases when bias isn't present, the results of the sample will get closer and closer to what's true of the population. Because when you increase sample size, you add more participants in the or in the study, then it becomes more representative of the entire population. Does that make sense?
Oh, okay, that's how you said it would be more representative of the entire population.
Yeah.
Okay.
Design an experiment. Be sure to include a description of how you assign individuals to each treatment group. This is. Does anyone remember?
Is this the simple random sample with the hats and the
Yeah,
calculators and stuff?
the hat. The hat is the most common
Oh,
one. That's what I prefer. I don't.
that's the easy. I wanted to know on the test, will I have to write? Will I have to use a? Will I have to use a calculator method?
No,
Will I have to
it's
explain that?
no. I
I
prefer
don't.
if you use hat method because that's the most common thing used on the scoring guidelines of the AP exam. But you can use whatever you prefer. If it just tells you to design
Oh,
an experiment, you can do hat. You can do random integer. You can do random integer table. It's however you prefer to do it that you can answer the question.
For the
okay.
hat, I
I
just
was
say
wondering about
typical
that because
example.
if it was on the test.
Yeah.
Oh,
Ian, what were you saying?
instead of for the hat method, could I just use the word identical instead of like all of the extra details?
Saying like identical slips of paper, label each paper
Yeah.
identical slip. Yeah, you can say
Okay.
identical.
Oh, for the hat method, I was wondering. So if I need like 50 students to randomly to like if I need to assign 50 students treatments, right?
Mm-hmm.
Would it work to get 25 slips of one treatment and 20 another 20 then 25 slips to the other treatment? And then instead of like putting the students' names on in the hat to randomly
Um,
assign.
w- can you ask that again?
All right, wait, oh my bad. So if I was to like if there's two treatments
Mm-hmm.
and there's 50 students that I wanted to assign it to, would I can I write the treatments on the pieces of paper rather than the student, or rather than writing the students' names on the pieces of paper?
No,
No? Okay.
because then you'd
Oh,
randomly select treatment and not who goes in each treatment group.
okay.
So I'm gonna just go over, I'm gonna use your example. So let's say you're trying a new drug and you're doing it with a sample of 50 students. You're gonna label, I'm typing this out, I can't be bothered to write this. You're gonna label um, each student with a number 1 through 50. Then you're gonna label identical slips of paper with numbers 1 through 50. Place them in a hat and mix well. Select 25 slips of paper and students with a corresponding number will be assigned to group 1 to receive treatment. The remaining 25 students will be assigned to group 2 and will receive a placebo. That's how you would write this question out.
Um,
Okay.
I had a question about that.
Mm-hmm.
Um, I don't know if you guys answered it, but like instead of putting the names, could you like write treatment one 25 times and then treatment two 25 times and then mix well and then assign each student to there, or do they want the names?
They want the names because that way you're assigning,
That's what
you're
I just said.
randomly assigning who goes to what group rather than randomly assigning or randomly selecting treatment, which I mean, I think you could make it work, but it's just so iffy, there's like no point in doing it. Do you know what I
Okay,
mean?
okay, okay. Yeah, yeah, yeah. Okay.
Yeah. Um, okay. Explain whether the study is experimental or observational. I'm gonna put this on the screen. Explain whether the study is experimental or observational. What's the main difference between these two?
I have an
One has a
answer.
control. Oh, sorry.
Gavin, go ahead.
Um, one treatment is being inflicted, and for experimental and observational is that you're just observing what happens basically,
Exactly.
or no treatment.
No treatment is assigned in observational, and treatment is assigned in experimental. That's how you differentiate the two. That's like the main
Okay.
difference.
And isn't there like no conclusions can be made if it's an observational survey, but conclusions can be made from experimentals?
If it's observational, you can conclude association or a relationship between the variables. All the linear regression things you had done were came from observational studies, but then experimental, you can conclude a cause and effect relationship between the
Oh, cause and
variables.
effect. Okay, yeah, yeah, yeah.
Causation.
Yeah, you can conclude causation. And then like I said, observational, you can only conclude a correlation or an association between two variables. Um, recognize the explanatory and response variable. Let me write this. Gavin, what's the difference?
Um, the explanatory variable is explaining what happens to the response variable.
So what's another word for explanatory variable?
Um,
Mm.
It's the manipulated variable. It's what you're changing. So it'll be like it'll be the treatment. It'll be that new drug you're administering or the lack of that drug. Does that make sense?
Mhm. Yeah.
Then a response variable is what you're measuring. So if you're measuring blood pressure, then that would be your response variable, the level of blood pressure, whatever it is, however that's measured. I forgot. So yeah, explanatory is what's manipulated, response is what's being measured. 7. Explain the statistical meaning of the word significantly in the context of a given study. Let me get rid of all this. Gavin,
No.
or does anyone have an answer? I need to stop calling Gavin. Okay,
No idea what this means.
so let's say you concluded that the results of the experiment were significant. What does that mean?
Wait, you said right. I concluded that the results were significant.
The results of an experiment were significant.
True.
That means that you found that the explanatory or the response variable was caused by the explanatory variable alone. So you recognize accounting for confounding variables.
So you recognize the causation? Or
Yeah, that there is a causational relationship between the explanatory and response variable. There is definitely a causational relationship. That's what the word statistically significant means. And the chapter after
uh,
this one, you're gonna find how to conclude statistical significance, which is hypothesis tests or
wait,
significance
so
tests.
if it's statistically significant, that would mean that is it like there's definitely
Cause and
what's it
effect
called?
relationship.
Wait, never mind.
so it shows whether the experiment is valid or like if so a statistical meaning is like if there's a cause and effect relationship in the experiment.
Yeah, if the
Good.
results are significant, then you know that there is definitely a cause and effect relationship between the
Okay.
Okay.
explanatory and response variable. And then, given a controlled experiment, describe how it was controlled and explain the purpose. I have another FRQ that we also did at Talon. Wait, did I already do this?
Uh, yeah,
Yeah.
yeah, we did this.
Yeah, I put this twice. Then you guys know it's that there is no treatment. And then in match pair designs, the control is yourself because you're comparing to yourself. Control is whatever the basis of comparison is. Does that make sense?
Wait, so or match pairs yourself?
Yeah,
Uh,
you are the control because you're comparing to your own to your like results without treatment. Does that make sense?
okay.
That
Yeah.
was
I
what
was
was
also so is match pairs also like if you have two blocks of subject and and they switch treatments, that would also be matched pairs or no?
um what do you mean two blocks of subjects?
Like not two. No.
Because if
Oh.
let's use the gender example. Oops. Yeah, no, girl and then boy.
Mm-hmm.
And there's
And they
treatment
switch
one and there's
treatment.
control and then there's treatment and control. These guys are already receiving the same treatment. They wouldn't switch treatments
Oh.
because yeah. Does that answer your question?
I, I mean like if there's like more than one treatment,
If there's more than one
right?
treatment,
And
yeah.
and there's like if like the one question where the let the left eye and the right eye and those one group left read with their left eye and the other group read with their right eye.
Yeah.
And then afterwards the first group would switch to their right eye and the other group would switch to their left eye.
Yeah,
Would
that
that be
would be
match
match
pairs
pairs
also?
because they
Okay.
receive both. Each individual receives both treatments.
Okay.
Because in a block, within each block, they're gonna receive both treatments, but each individual will only receive one. So like individual two that you randomly decide to control, they're only gonna receive the control, but match pairs they'd receive control and treatment.
Okay.
Yeah. And then the last question on your review is recognize a parameter. Parameter is a measure of a population. So things like population proportion, which is just p, and then mu, which is the mean of a population, and then statistic applies to samples. So that's going to be your sample proportion, p hat, and then x bar, which is mean of a sample.
Oh.
Then, yeah, that's it. That's everything on the review. Do you guys have any questions?
This is gonna be on. Is this gonna be turned into a YouTube video
Yeah.
to rewatch?
Yeah, yeah,
Cause
yeah.
I missed the first 10 minutes. I think.
Yeah, no, this is a video. And then also,
Okay.
Okay.
I'm gonna I'm gonna post all these notes and then all the MCQ and FRQ from the Talon in the Discord.
Oh.
Yeah.
Okay.
Any questions?
That works.
Okay, I'm gonna end it
No.
then.
Um,